Humans are the only species capable of building their own prison and calling it home. When the waters devoured the continents, the ancient nations quietly fell apart. There was no final great war. There were no final speeches. The map simply ceased to make sense. Instead of countries, refuges emerged. Instead of borders, hermetic doors. Thus were born the arcologies, also known as capsules, self-sufficient cities sealed against a hostile outside world. They produce their own food, their own water, their own energy. They are technological fortresses suspended above a world that no longer forgives mistakes. Over time, these capsules ceased to be emergency shelters. They became kingdoms, political islands, small universes that needed no one else. Humanity did not unite to survive. It fragmented. Today, the planet is divided into 4 forms of civilization that share the same world without sharing the same idea of humanity. On this journey, you will get to know them, and perhaps you will understand that there is not just one future. The future is all the ones that the species was able to invent in order not to disappear. Subscribe for more stories about the future. The idea of inhabiting Mars is not new. Since the 20th century, scientists, writers, and visionaries have imagined what it would be like to transform an arid and hostile planet into an environment suitable for life. What began as science fiction soon became a real line of research. During the 21st century, the first manned missions to Mars were launched. Accompanied by ambitious studies on terraforming, (3D) printing of habitats, and biological adaptation. Despite the enthusiasm, resources, reduced gravity, and lack of a breathable atmosphere made terraforming seem unattainable. However, the need to expand beyond Earth, marked by climate change, overpopulation, and resource depletion, made Mars a strategic priority. The dream of transforming Mars went from being a scientific curiosity to a common goal for humanity. In universities, laboratories, and space agencies, the first phases of the plan began to take shape. Although it would be centuries before that dream could be realized, the seed had been planted. During the 21st and 22nd centuries, a small group of visionaries began laying the theoretical and technical foundations for terraforming. Among them were astrobiologists, geoengineers, planetary architects, atmospheric experts, and closed ecosystem designers. Many came from disciplines that, until then, had not been related to space exploration. Synthetic biology, climate engineering, and environmental neuroscience. The initial plans were as ambitious as they were risky. Some proposed detonating nuclear explosives at the Martian poles to release CO2 and raise the planet's temperature. Others designed giant orbital mirrors capable of reflecting sunlight onto specific regions. There were also attempts to introduce extremophile microorganisms capable of generating oxygen. Although several of these trials ended up getting out of control and had unpredictable consequences for the Martian ecosystem. Not all failed experiments were dangerous. Some were simply absurd. From rain generators based on sonic impulses to plants designed to sing when they detected optimal levels of carbon dioxide. Although they did not work, these attempts reflected the human desire to explore every possibility, no matter how improbable it might seem. Early successes were few and far between, but they paved the way. The scientific foundations were laid, and little by little, the first viable strategies began to emerge. Terraforming was no longer just a hypothesis. It was a project in progress. Terraforming Mars was not just a matter of science. It was also a test of human endurance and patience. There were moments when everything seemed on the verge of collapse. When the dream of making another world habitable came up against the harshness of that very world. The first major obstacles were political. As Mars gained strategic value, old terrestrial tensions shifted to space. Corporations, states, and alliances began to dispute ownership of regions, resources, and technologies. For more than half a century, progress was slowed by legal conflicts, cooperation blockades, and covert sabotage. But the most profound challenges did not come from politics, but from the planet itself. Mars was unstable. Its atmosphere was volatile. Its soil was unpredictable. Systems failed. Dust storms ravaged fragile structures. A chain of failures in the thermal reactors at Planum caused a total blackout that left 3 colonies isolated for 41 days. There were accidents that did not appear in public reports, and decisions that are still considered ethically questionable today. Such as the mass release of microorganisms without long-term studies, or the closure of rural stations that still housed human life, considering them unviable in the climate model. Not everything was technical or logistical. There was also emotional strain. The first colonists lived for decades without sky, without trees, without rain. Depression due to isolation became one of the main causes of mission abandonment. Some families returned to Earth, others simply disappeared into the dust. And yet, each failure left a lesson. Each collapse forced them to redesign, rethink, and persevere. Little by little, new protocols, new laws, and new forms of cooperation were established. Above all, one idea emerged. Terraforming Mars was not just about changing a planet. it was also about changing those who attempted it. What came next was not immediate. It was a slow, patient march, built layer by layer, a process that lasted centuries and demanded all of humanity's creativity, patience, and adaptability. Turning a hostile, cold, airless planet into a habitable world required 5 phases, dozens of new disciplines, and thousands of mistakes. But it was achieved. It all started with ice. For millennia, Mars had vast deposits of frozen CO2 under its poles and in the subsoil. Waking up the planet meant releasing it. Thousands of geothermal catalysts, self-sufficient towers powered by fusion, were installed throughout the southern hemisphere. They injected heat through deep thermal resonance pulses, breaking up the permafrost and releasing carbon dioxide on a large scale. The artificial greenhouse effect began. Over the next few decades, the planet's global temperature rose 38 degrees. With the increase in temperature and atmospheric pressure came humidity. The first Martian fog banks were not natural, but induced by sky factories, floating platforms suspended by electromagnetic levitation, which synthesized breathable gases. They used helium-3 imported from the Moon and ammonia transported from Jupiter's moons as a base to produce oxygen, nitrogen, and water vapor. The gases were released in layers calculated to the millimeter. Each release was measured, adjusted, and contained. As the sky became denser, it also became bluer. The red planet was beginning to cease to be red. But air was not enough. Life had to be sown. The laboratory seeds were designed for a single purpose: terraforming. They were bioforms created using synthetic biology, resistant to radiation, capable of metabolizing Martian regolith and releasing oxygen as a byproduct. Among them were crystalline root lichens, fungi capable of absorbing toxic metals, and dual-phase algae that survived in both puddles and suspended dust. These organisms were released from low orbit using self-replicating capsules. Each capsule seeded an area and then degraded into nutrients. Within a few years, the once barren rocks were covered with patches of green and purple, microscopic, but alive. Then came the water. Not loose water, but the first seas. Hellas Planitia, the largest impact basin on the planet, was selected to contain the first. The operation involved melting polar glaciers using orbital lasers, constructing underground transport channels, and sealing the bed with self-repairing nanopolymers. Once contained, the water was oxygenated and seeded with bioluminescent phytoplankton. The sea glowed at night as if it had a life of its own. Along the equator, seasonal rivers and low salinity lakes began to form. Some arose spontaneously. Others were designed by teams of river eco-engineers working with long-range climate models. The next challenge was the climate. Mars had no magnetic field, and without protection from the solar wind, the atmosphere would be lost again. 5 orbital magnetospheric shields were built, positioned at Lagrange points. Each generated an electromagnetic field the size of a continent. For the first time in its history, Mars had a natural defense. With the climate stabilized, the atmosphere breathable and water flowing, vegetation arrived. Unique species were designed for the Martian ecosystem. Aerial root trees, which breathed through their branches and fed on dust. Hyperbaric ferns, which accelerated oxygen production during cold nights. Thermal balance plants, which regulated soil heat and served as natural climate control. These artificial forests spread out in a mosaic pattern, adapting to the terrain. Their roots stabilized the soil and reduced the intensity of dust storms. The winds now carried spores, moisture, and scent. Along with vegetation, agriculture was also born. The first Martian farms were not under domes, but outdoors. Vertical crops of plant proteins, edible algae, and adapted cereals spread across temperate zones. Nutrients were generated by synthetic worms that aerated and fertilized the soil. Crops were grown without importing a single molecule from Earth. The food and climate systems were connected to a global network of climate AIs that adjusted, predicted, and balanced every variable on the planet. A kind of artificial Martian consciousness, distributed in nodes throughout the planet, ensured that life continued its course. In the highlands, where the air was thinner, biotic exchange towers were installed. White structures that absorbed polluting gases, released oxygen, and transported moisture to arid areas. They were known as the lungs of the sky. Over the centuries, the rhythms settled. Mars began to have seasons, although different from those on Earth. Longer sunrises, less harsh winters, and a deep blue twilight that only exists there. Today, when you walk through the forests of Valles Marineris or look out over the Hellas Sea, it's hard to remember that all this was designed. That every drop, every breeze, every leaf was a human decision. That Mars, now habitable, was once just rock. The centuries following terraforming were no less complex. Transforming a planet does not end with making it habitable. It begins there. Mars still presented challenges that could not be solved by engineering alone. Low gravity altered key biological processes. Radiation, although controlled by orbital shields, continued to affect generations born there. The soil, still mineralistically unstable, required constant monitoring. And the atmosphere, although breathable, required permanent maintenance. New balancing systems were then created. Artificial microfaunas designed to complete food chains and recycle organic waste. Smart fog systems, which maintained environmental humidity at optimal levels. And environmental memory networks, capable of simulating entire ecosystems, comparing variables, and anticipating imbalances. Martian life was organized around nested cities, interconnected urban centers, integrated with the landscape and sustained by geothermal energy. They did not grow vertically, but inward and toward the ground. Porous streets, living walls, photosynthetic roofs. Everything was part of the planetary ecological system. Martian cultures developed new ways of inhabiting time. The longer days gave rise to a different rhythm of life. The seasons, different from those on Earth, marked holidays, crop cycles, and rest routines. And the generations born there, who never walked under Earth's gravity or saw blue rain, began to call themselves indigenous. The last elements needed to complete the process came with time. The moisture belts stabilized. Atmospheric recycling systems were perfected. And symbiotic life forms were incorporated that helped to completely close the basic ecological cycles. Carbon, nitrogen, phosphorus, and water. It was no longer an experimental planet. It was no longer a settlement. It was a complete world, and it was ours.